addition to, if it's injected, it's only going to be the IgGs. Secretory antibodies. Can be delivered orally. Okay, I'm not going to be obsessive about this. You guys write it correctly, okay? Can be delivered orally, and they, that can give you the IgAs. And that is really important for little children who might be ingesting, the infectious agent in unclean water or, getting it on their hands for gastrointestinal pathogens. So in addition to the IgGs, if it's an injectable vaccine. Okay. There can also be nasal ones, like the FluMist one. Okay, so let's see. Longer term, this is going to be the most effective type of response. That would be generated if you were exposed again. Let's see what else. Longer term, it can multiply, so it can help with herd immunity because it can spread to other people, right? So that can help. I guess that's another kind of advantage. Can help achieve herd immunity in a population where not everybody, if they can't get the vaccine to every little child, it can still spread maybe. All right. It's pretty good at stimulating a response. Anyway, those are all advantages. There's one big disadvantage, though. So these are all advantages. What's the big disadvantage?
Make you sick and kill you, right?
It could make you sick. Yeah, so it can cause symptoms. And by symptoms, what we mean is the vaccine itself. That weakened pathogen could actually cause symptoms. Yeah. When we think of symptoms, parents worrying about their child's symptoms in response to a vaccination, usually those symptoms are the child's immune system, the inflammatory response, that might have a fever or something after getting vaccinated. So you give them Tylenol to try and prevent that. And those kind of symptoms are not caused by the actual vaccine, but by the immune response to it. So that's different than this. In this case, what we're talking about is the actual vaccine causing symptoms, not just as far as, the person's immune response to it. So when they were considering when they were worried initially, I think it was the first Bush administration, he was worried about smallpox bioterrorist activity, and he was like, let's vaccinate everybody against smallpox. But then they figured out that because it was an attenuated vaccine, the risk of really bad effects of it was way too high to warrant such a thing. Like, that was a ridiculous notion. But still, medical providers and military personnel did get vaccinated for smallpox for a while there.
I don't know what the difference would be between making you sick because of the immune response, because it is your immune response.
Oh, no, it's a difference. No, because, like, for example, let's use that smallpox attenuated vaccine as an example. It's a virus that replicates in the skin, so it can cause a skin, not inflammation so much as it's actually multiplying in the skin. It can cause blistering and rash and discomfort and pain and, yeah. The two things are related, but like a normal, but the symptoms would be more specific in this case for the particular infectious agent that the vaccine is, because the vaccine is actually that agent, only a weakened version. So it wouldn't be as general as just like a fever or something.
So like a different vaccine might not actually have, it might have markers on protein markers, but not actually that virus.
Oh, yeah, of course. Yeah, each one would be totally specific.
Yeah.
Yeah, yeah, and have different. So the polio virus one that's weakened can the other possibility too, it can actually change. It can mutate. It's very unlikely. So see, it says very low. But it could possibly change to a form that causes symptoms in more, in more people. It's more likely to cause symptoms. So a more virulent, form. So that is a disadvantage. As far as the non-specific type of response to a vaccine that parents worry about when, getting their children vaccinated, they've done studies that show, so who has a stronger immune response to things? An infant or an older child? What do you think?
Older child.
An older child has a stronger immune response, right? Because an infant's immune system is very immature. So what they've shown is actually that when parents wait and they hold off on their vaccines and they don't start with the vaccines right on schedule when the baby is really young, it's more likely that the child who's older is going to have a fever and an inflammatory response to the vaccination because their immune system is stronger now and is going to respond to something foreign more than if they had started when that child was a tiny little baby and their immune system was still very immature. That's when they tolerate the vaccines much better. So it's contrary to what the parents are trying to achieve, which, they're worried about their little teeny infant having an immune response to, and getting a fever and maybe getting, neurological side effects of the fever. But waiting actually increases that chance that it could happen. Anyway, and plus as an infant, they could be exposed to something that they can't protect themselves against that's too virulent. Okay, so the vaccine itself is not disease causing, but in some people whose immune systems, are really suppressed, it can cause symptoms. So this would be in susceptible people, very susceptible people. Okay. So that's a big disadvantage. All right, the inactivated vaccines. There's lots of different types. There's subunit vaccines, and there's inactive bacteria or viruses, and there's inactive toxins. And polysaccharide that would be a capsular polysaccharide. There's a really effective vaccine that's wiping out Neisseria meningitidis in Africa. So has anybody heard of the meningitis belt in Africa? Lots of little kids under age of 5 would die of meningitis caused by Neisseria meningitidis in Africa. But a vaccine was developed and made available in those countries for really cheap, super cheap, in 2010, and now that meningitis belt doesn't really exist anymore. It's really rare now for kids to die of or to get meningitis now because they're vaccinated. So anyway, so lots of inactive vaccines. Most vaccines that we have are inactivated vaccines. Lots of different types. There's one big advantage. What's the one big advantage? We can't. Yeah, they're safe. The